All right, we had a bet going on to see who was going to dance on this music, but none of the speakers did that. Okay, it's shortly past 5, and I think, Christophe, we need to work on our branding. The next session could be called 5 by 5 at 5. We have a fantastic lightning talk from 5 startups. We've given them 5 minutes, and I'm super happy to introduce my colleague, Katerina Madeira, who's going to introduce each of the startups. Katerina.
Thank you very much, Olivier. It's great to be here to showcase a very small sample of startups, part of the Startup Exchange program. Just to give you a very brief introduction about our program, Startup Exchange is led by MIT Corporate Relations, which is home as well to ILP, as John mentioned earlier today. While ILP primary focus is to connect with and support large corporations such as Bouygues, at Startup Exchange, we start by identifying and selecting MIT-connected startups. And this connection might come through the founding team, the technology, as well as startups that, although don't have origin at MIT, they are heavily supported by other groups at MIT, like The Engine or Start Nano from MIT Nano, just to name a couple. And then, together with ILP, we foster collaborations between both parties. And so today I'm very happy to introduce, to call on stage 3 companies, one at a time. And the first I'd like to call on stage is Lamarr.ai. We have John Fernández with us today. He's a professor at MIT and director of MIT's Environmental Solutions Initiative, as well as a CSO and co-founder of Lamarr. Lamarr is leveraging robotics and AI to design impactful solutions for the built environment.
Thank you. Very nice to be with you. So I'm presenting my company when the slides come up. Lamarr.ai. And can we have it on these screens as well? Or one of these screens? No? Okay. Lamarr.ai, an autonomous solution for rapid building envelope diagnostics using aerial robotics and cloud computing. Clicker not working. And I am definitely pressing the right button.
The technology ends at 5 o'clock.
Well, should have told me beforehand. Clicker not working. Well, I could tell you about my company. Okay, great. Okay, so very quickly, we know very well the challenge of the century is climate change. The built environment is a major contributor. We also know that the IPCC has designated the built environment, buildings and cities, as the smartest dollar you can spend to reduce energy consumption and greenhouse gas emissions. Today, in the United States, there are 10 million commercial and multifamily residential buildings, and they are now being regulated under more stringent energy and carbon emissions codes. So 61% of all construction today are projects in retrofitting, improving the efficiency of the exterior envelope of those buildings. And so the active envelope retrofit industry, we suspect, will grow tremendously, maybe even doubling in a year or two. Also, 50% of US buildings have been built before 1980, and those buildings are rapidly aging. So that 40% of energy losses are from the envelope, an enormous percentage of energy losses from the built environment. Today, the auditing process of exterior envelopes is done almost completely manually through site visits and interviews, equipment, expensive equipment, and then reports are put together by building scientists, building experts. The available envelope analytics and audit process is therefore not easily scalable, not scalable really in any good way. So we founded Lamarr.ai on the basis of research funded by the US Department of Energy. It's the tool that we have produced. The product is like giving the building envelope an MRI scan to autonomously detect thermal defects in the exterior envelope. It is an integrated autonomous solution for rapid building envelope diagnosis, which includes the data collection itself, the use of computer vision to identify and then to analyze those thermal anomalies, and then inputting those into a 3D model, a digital twin that then produces an energy model. So the company provides any one of these or a subset of these or all of them, flight planning, data collection, image processing, automated image processing based on a machine learning model, geometry construction using RGB images and photogrammetry, and energy modeling. By way of thermal images, as I said, we have a machine learning model that identifies and then classifies those thermal anomalies and then places them on the photogrammetry produced 3D model. Those anomalies in yellow that you see there are tagged, they're identified, and they then lead to the building energy model. Today, our algorithm sits in the cloud, and a user uploads those images. The analysis, we can analyze 1,000 images in under 1 second to give you the identification and the classification. And then the user can click on those anomalies to then decide how to repair, how to respond to that thermal anomaly in the building. Our technology saves 85% in time, 90% in cost, and is safer and more accurate because you don't have people at the site climbing buildings or on scaffolding with a handheld thermal camera. The 3 elements of the service that we provide, generally aerial data, thermal inspection, and energy modeling, are serviced by these companies, and we know all of these companies very well, but we're the only company that provides broadly all of these services in an automated package. So we are essentially a software as service company. The market is about 150 billion globally, 41 billion for US retrofit, and 22 billion the envelope retrofit market. In particular, our beachhead markets are New York and Boston, although our contracts now are national in the United States. Our 2 revenue streams is the first product is for large building operators, owners, and managers to upload data, have it diagnosed, and then to repair. And our second market is, which we will start in about a year or so, is the homeowner who also captures images using a smart camera, a thermal camera on a smartphone, uploading images, and then we diagnose, and they then do their own repair. It's a completely scalable solution. In fact, we are already exceeding the number of units that we've analyzed that's shown on this curve. And the team that we've put together bridges the core competencies needed, from building science to robotics, machine learning, and computer vision. These are my colleagues at Georgia Tech, my PhD student and now postdoc, and then a professor at the Syracuse University. So, okay. So just an explanation on the name. We are dedicating the name of our company to Hedy Lamarr, inventor of signal hopping technology, which is used originally in radio and now in Wi-Fi technologies, and to all innovators who did not gain prominence for their inventions during their lifetime, especially women. So we are Lamarr, an integrated autonomous solution for building envelope diagnosis without the audit headache. Thank you.
Thank you very much, John. And now I'd like to call on stage Diana Nielsen, Head of Business Development of Swift Solar, that is building solar for the next generation.
Hi, everyone. Just waiting for the slides. Great. Well, thank you all for coming today. We love MIT ILP and have a strong relationship with MIT. Our CEO, Joel, did his PhD there, and 2 of our further co-founders did postdocs at MIT. So we're really happy to be a part of the overall startup ecosystem. As Katerina mentioned, Swift Solar is building the next generation of solar cell technology. Solar technology has a really key role to play in the energy transition. Here in Europe, you see the Repower EU plan that's aiming to deploy an additional 420 gigawatts of solar over the next 10 years. In the US, we're projecting there's going to be a tripling of solar deployment due to the recent Inflation Reduction Act. And still, we're trying to deploy all of the solar with technology that's been around for 60 years and hasn't really improved in the past several decades. At Swift, we think it's time for something better. And we think that technology can be perovskite tandem solar technology. Perovskite refers to a class of crystals, which you see visualized here, that have really strong solar absorption properties. We're building tandem devices, which means that we stack one of our perovskite cells on top of another cell, either another perovskite cell or a silicon cell. We're able to tune the band gaps of the individual cells so that they're each absorbing different wavelengths of light, and the efficiency of the overall device is higher than either of the cells would be individually. So if you look at the existing technology landscape for the solar industry, you can see that it's dominated by silicon. Silicon is manufactured at really large scales globally, which means you can make it very cheaply. And it's also pretty efficient, around 22% for the best available commercial silicon. Many technologies have tried to replace it, from gallium arsenide to organics to other thin film technologies. And we think that they've all failed because they haven't checked both of these boxes. They haven't provided a superior product in terms of efficiency, and they haven't delivered better unit economics. We think that perovskite tandems offer the first opportunity to check both of these boxes, providing high efficiency solar for very, very cheap. We think this is particularly exciting because when you have high power output, high power density, you're really expanding the way that you can use solar. And that's reflected in our go-to-market strategy. We're working first in what we see as emerging solar use cases that I'm gonna touch on 3 of those. So for wearables, today, we can double the battery life by replacing existing amorphous silicon with perovskite solar cells. In the LEO satellite space that currently uses gallium arsenide, a very efficient but very expensive product, we can lower the process solar arrays by a factor of 10x and also deliver similar levels of durability under space conditions. Lastly, in the EV market, until recently, it was kind of crazy to think that putting solar cells on a roof could actually improve the performance of your EV. But with high power density solar, we're currently working with the California Energy Commission to add 20 to 70 kilometers per day of range to EVs by putting solar on their roofs. That means that in a sunny place like California, where we're based, you can go up to 6 months without recharging your EV. And here's a picture of one of those EV modules that we've made. So outside of these emerging use cases, we can still add value in traditional solar markets by boosting solar output by up to 50% and by reducing system costs. So in the rooftop market, what this means is that because we have higher efficiency solar, we have to cover less of a given roof to deliver the same solar output. That means that all the costs related to mounting on our roof can be significantly lower. In the utility scale segment, similarly, we're boosting power output and reducing LCOE by lowering costs like land acquisition costs and racking costs. We're essentially delivering the same solar power output with a smaller solar farm. Yeah, Swift is excited to be here in France and open to developing new strategic relationships. In our initial markets, EVs, aerospace, and telecoms, we're looking for initial distribution partnerships and early customers. For our medium-term markets, C&I and utility-scale solar, we're looking to learn more about customer technical requirements and also to deploy initial proof of concept projects. My email address is there, so feel free to reach out or come find me during the cocktail session. Thanks for your time, everyone.
Thank you, Diana. Next, we have Who with us, Ecology for the World, or for the People, and Borja Soriano, COO and Partner, will tell us about the company.
Good afternoon. I'm Borja Soriano. I'm the CEO of Woho Systems. And we're here today to talk about why the company was founded and asking for new partnerships. Something that was mentioned before, as you know, the construction generates around 40% of the total CO2 emissions, and we use up to 36% of the total annual energy use. But today, there is a solution. These clean, renewable energies allow us to produce energy on-site and even, as was mentioned before, to compensate the embedded carbon during the operational life. So then the burden of the CO2 belongs to the materials. After 30 years of practice, MIT professor Antón García-Abril, along with Deborah Mason and the team, we have been researching different materials, different construction systems, such as pre-stressed concrete, steel frame, GFRC, nanocrete, and CLT. And the conclusion that we got is that to have the best product, we needed to take the best of all these worlds and combining them. So today, in our product, we use the CLT for the non-structural elements and the nanocrete, that is carbon with GGBS to reduce the clinker, for the structural elements. So usually these materials and these energies are super expensive. So the only ways for us to make an affordable product and to always certify and guarantee the quality of the product was through industrialization. We have integrated from day one all our suppliers, and they have been helping us to avoid redundance and unnecessary movements, to avoid waste materials. And we have integrated from day one also simplistic suppliers, logistics, and supply chains. And once we have the perfect materials, the perfect energy, and the perfect construction system, we needed technology that allows us to measure, audit, and certify all this product and all this process. So here, for example, in this video, you can see how today BIM models allow us to integrate in one single file all the construction disciplines. We also embedded in this file all the material properties, weights, volumes, etc. And all the information is there. As you can see here, we can perfectly jump from the digital world to the physical prototype, and it's perfectly matching. So once we design one unit, we just need to test it, certify it, run all the tests on it, and then we have what we call the pixel or the Lego piece. And once we have designed this, we just need to combine it to create different buildings. And like Lego pieces, we can play with them to combine and to generate totally different buildings. This is, for example, how we solve the standard real estate layouts for 1, 2, and 3 bedrooms. We also have layouts for offices and all the amenities, etc. And something really important is that everything I have already explained is how all the product-based industry works. And it's obvious that in architecture or in buildings, when we talk about industrialized systems, people usually dislike them because they think that the building would be soulless, would be repetitive, it's not going to be connected to the place. So that is why in Woho, even though that 90% of the building remains always the same, what we call the core, we always have the mask that is per project, that makes every project unique, and this is something that we design with the client to comply the client requirements and a lot of times some code requirements. And I would like to conclude saying that in Woho we sell carbon neutral affordability, art and tech, and we use prefabrication to achieve this. It's not that we are a prefabrication company. And as I said before, we are here today because we are willing to partner with investors, GCs, developers that have the same mission and vision that we have in Woho, the ecological and social mission. And we think that the Bouygues group can be really helpful for us, especially the construction and real estate team, not only in France, but also in all the countries they operate. Thank you.
Thank you, Borja. Next up, we have Yubik, a startup supported by Bouygues that is working to make embedded systems more efficient. I'd like to call on stage Justine Bonnot, founder and CEO.
Good evening, everybody. My name is Justine, and I'm going to present you what we are doing at Yubik for the efficiency of all your embedded solutions. Currently, we are surrounded by numerous and very, very complex electronic devices. You have a few examples just right behind me. These objects, they are planned to exceed 75 billion by 2025. These electronic products, they need to be powered by energy so as to power a software that performs a certain task. And their complexity leads to a real problem in the energy global consumption. As it has been said before, digital has its share of responsibility in the global energy crisis. It's really easy to think about what is software when you think about you download PowerPoint, you install it on your computer, but here I'm mostly talking to you about all the invisible software that is around us. For instance, in your cars, in your smartphones, in GPS, in satellites, and even in your household robots. All this software, because of the global energy crisis, needs to be optimized before being embedded on the products so as to be sure that it consumes only the right amount of energy when it is powered and when it works. The problem is that in real life, during an embedded development project, this is generally not the case. Why? Because the optimization phase is a really, really complex and long task. So generally, or it's not done at all, and the product consumes a lot more energy than it requires, or it's partially done, and there is a real waste in the energy that is consumed by all these electronic devices. And we must put an end to that. And this is our raison d'être at Yubik. For that, what we have built is two software tools for embedded software developers. They use them as real companions during the development phase of their embedded project. The first tool is composed of the blocks in pink, and it's here to give a lot of information about how behaves the source code that the embedded developer is building. The rest of the blocks, I'm not going to talk about it a lot in this presentation, but it's there to do the optimization. I will just give you a little bit more information about the first analysis tool. The goal is to give a few information about, for instance, where the time is spent in my application. Is it in computation? Is it in memory operations or in control? Then we will give the information to the developer if there is any bottleneck in the energy consumption or in the latency or memory. And finally, are there any optimization potential in the source code? We give also information about this optimization potential. How many energy can you save by doing this optimization? And of course, the second tool does this optimization. The first tool is planned to be launched in the beginning of 2023, and the second tool is planned to be launched in the summer 2023. Our business model, we sell both licenses of our tools and services. The licenses, the prices depending on the duration and on the number of users. And about the services, because we are coming from research laboratories, we can sell different types of services, going from developing a real algorithm from a problematic or just optimizing the application. This project comes from my PhD research work. So I have defended my PhD in IETR in Rennes in 2019. And we had the chance to create a startup in April 2022 with Bouygues Telecom Flowers. And we are now a team of 8 people. And we work for several customers in varied sectors as customer electronics, industrial electronics, robotics, and automotive sectors. And of course, we are interested in partnership, business, scientific research. Of course, we still do a lot of research and teaching because we really think that it's really important to present the importance of the optimization to the next generation of developers. And I will leave you with a few figures about what we can do with our optimization tool. And thank you again for this opportunity to present Yubik to you. Thank you.
Thank you, Justine. And to wrap up the Startup Lightning Talks, we'll hear about Bovlabs, another startup supported by Bouygues. Jaikrishnan R Pillai, founder and CEO, will tell us about the company who optimizes every charge cycle for AVs.
The last startup, 5 startups, it's not 550, but it's 530, but it still makes sense. Let me give you some more energy.
Another five.
Exactly. So good afternoon, good evening, bonjour à tous to everybody, and thank you so much for, helping us to participate in this conference. It's a great honor. Thank you very much. So what we do? Well, we optimize every charge cycle for electric vehicles. Now, think about the vision. Electric vehicles are growing. You have the infrastructure needs to grow. Where is it growing? Well, it's in your home. It's in your commercial place, where there are other assets, whether it's your solar panel, whether it's your building, So that's where we need to integrate an EV asset within a local energy community or a renewable energy community. How to optimize it. How to make sure that you have clean energy. Prioritize when the sun is shining high, right? And also to aggregate the EV assets to create virtual power plants, to bring in flexibility to the grid. But I don't need to charge when there's a congestion issue in the grid, and I'm incentivizing people for it. So that's our vision. So what's the problem that we are solving? Energy price, simple. It's soaring. 500% increase in wholesale price. I don't want to see the reasons, but unfortunately it's the case. And then you need to integrate more renewable resources. If you look at the new law that comes in November in France, they say that 80+ car parks going forward in the next 5 years, you have to have solar panels. So in which case, you need to prioritize charging when the solar is generating more energy. Last, utilization of charging stations. I stay near in Paris here, and near to my place, there are 3 different charging points. None of them is utilized in the daytime. Most of it is utilized in the night. And the reason is, there's a fixed cost. There's no communication between the user and the operator to tell them, well, charging in the afternoon can be, more attractive. So that's important. And that's where we come in. We wanted to facilitate a more decentralized, distributed kind of environment that can allow optimization for charging. And our focus is fleet customers, charge point operators, and parking operators. So what's our solution about? Well, 4 different aspects of a solution. 1, we want to integrate with assets, whether it's solar, whether it's your battery devices, so that we have a smart agent which can aggregate data from these smart devices and then create energy transactions at less transaction costs using a blockchain framework as such. Second, it's the charge point management system, which engages with any charging stations which supports standard protocol to facilitate remote management of charging. And then the third aspect is better management of energy services. How to optimize using smart charging? Well, it could be a price of energy, it could be a demand charge, it could be a way of utilization of your vehicle. I might be actually at office in the afternoon where my sun is shining high and you want to optimize charging from it. That's the utilization that you want to optimize and to reduce your cost. And then, not just behind the meter, but also facilitating front of the meter optimization. How can I give value back to the grid? And that's the revenue, that new revenue model, that this is not going to happen if users are not participating. So there's an app which allows users to participate in the ecosystem, telling them there is a discount now if you want to charge up because you're getting more green energy, and telling them the impact. That's very important. The impact to the environment. What you're changing by charging at this station. Now, going forward, what we are looking at is we have a centralized kind of a charging ecosystem right now. Now, we want to move it near to the edges, where the smart agent itself can actually say when to charge, when not to charge. And we're looking at federated learning models in order to facilitate, to improve privacy, data security, cybersecurity aspects, and also looking at a better accuracy in terms of what EV flexibility it can offer. The market that we are looking at is the fleet market. I'll be quick. It's a fleet market, and the reason why the fleet market is important is because of the fact that that's the market that's looking at net zero emission target. And that's where we want to utilize our experience and expertise. We're also partnering with partners like Juriv, who are like e-mobility platform players or roaming platform players, of so many different charge point operators where we want to optimize their operations. Sorry. The 3 pillars that we wanted to work on is 1, reduce the total cost of ownership by optimizing the fuel costs, bringing new revenue models, and also linking the charging behavior to state of health of the battery. Second is the green energy aspects, how to certify the source of origin, when to actually say that the impact is important. And last but not least, the cybersecurity aspect also. The projects, just 2 minutes, I'm sorry. 1 minute, okay. The projects that we are involved with, we are part of SNCF Carrier Connections project at XTGV train station, working with Nissan on facilitating a V2G integration project. You as a customer, if you have a Nissan Leaf vehicle, you could come to XTGV train station, park your car, and facilitate in the ecosystem of facilitating auto consumption and flexibility for the local point and also for the grid flexibility as well. And reduce your parking fees. That's the important model that you're speaking about. We also, part of 3 different, I'm going to skip it, 3 different European Commission projects as well. And last project that we are working on is the one that, we are working with Bouygues in a makerspace in Easy Marseille. And this is very important in terms of looking at utility vehicles of corporates to make them move to EVs and optimize their charging operation. And this is going to be scaled to Le Fabric's kind of a construction place, which could have 65 charging stations and its optimization. Money is important. So we're looking for partners who can help us to grow and facilitate. Thank you. We are ready, and we want your partnership for it. Thank you very much.
So we arrive at the end. So we will keep your 5 by 5 at 5 concepts for the future.
Good.
So thank you again for all your presentation today. It was very, let's say, enthusiastic and a lot of energy, both with Roberto with his strong leadership and of course, Ariel and Carlo. But also this roundtable, let's say female roundtable, exceptional female roundtable about let's say the future and the next future concerning the climate. If I had to remember 3 things of this afternoon, I would say, first of all, we can see clearly, let's say, the firepower of university like MIT, and the fact that the link between the professors, the laboratory, and the students, let's say, bring real projects and real, let's say, startups starting, and that's very, very impressive. And this entrepreneurial spirit is key. And the last point, and I give you then the floor, is certainly after that, the diversity of this room with, let's say, all our friends, partner, colleagues, and all this ecosystem is absolutely key to grow together.
Absolutely, Christophe. And I just want to add a couple of things. I hope everyone saw convergence in action, what we discussed in some of the presentations. I'm thinking specifically of Ariel's presentation, mixing biology and chemical engineering. This is the future. This is how we stay relevant in this ecosystem, by bringing disciplines together and by having diversity as one of our key drivers. And finally, I'll reuse a word that Marilus used, the word impact. I think at MIT, we're all about impact of the work we do and trying to scale up the nano to macro that Carlos presented, and many of the exciting topics we heard from the startup. So we'd like to thank everyone, and we look forward to some further discussions with the cocktail reception. Thank you.